Hello, today we're going to look at simplifying square roots with variables. We're going to focus only on variables today, no integers involved, but in order to show you how to do the variables, I do have to review the integers part. So first I want to remind you of one of the methods of simplifying that's called using the factors, using the prime factorization. So we're going to look at the factor method of simplifying a square root. And show that it models exactly the same. So our factoring method that we practiced, we would need to break down our integer. Since it's not a perfect square already, we need to break down this integer into its prime factorization. So one technique is using our factor trees. So I know that 2 times 9 is 18, and I can also break down the 9 3 times 3. That reminds me, of course, that the square root of 2 times 3 times 3. That is another way of writing the square root of 18. So I have it broken down into its factor trees. Now what I was looking for there was any pair. So you can notice right here I have a pair of 3's. Now remember, anytime you have a pair, that ends up being a perfect square. So I'm going to take that pair out, put it in the front because it's a perfect square, so that's a 3, and then whatever's left over goes on the inside. So my answer here would be 3 radical 2. Now we're only going to focus on variables today, but you're going to see that this technique is exactly the same. So we're going to start with a simple one. Let's start with the square root of a squared. Square root of a squared. Well, I want to break this down into its prime factors. Well, we know that if we have this in exponential form, I can write it out in expanded form, and that would be its prime factors. So I can skip the factor tree, and I can just jump all the way down here. I know that a squared is really a times a. With that in mind, I'm going to follow the same technique I did here. If you'll notice, I do have a pair of a's. So I'm going to take that pair of a's, cross it out, and of course that a is perfect. Now there happens to be no leftovers on the inside, so my answer here is simply a. And what I just found out was the square root of a squared is a. Alright, let's extend this and say that it has a bigger exponent. So let's try another example here. How about the square root of x to the 6th power? Square root of x to the 6th power. Again, just like the factoring method, I'm going to break this down into its prime factors, and I can skip all the way down. Of course, I don't need that much space, but I'm going to skip all the way down. I know that x to the 6th is really x times x times x times x times x. I have 6 of those x's. Well, just like before, I'm looking for pairs. So here I was finding a pair. Well, in this case, you notice there are 1, 2, 3 pairs of x's. Well, each one of those pairs is perfect. So if I put all that together, I know that x times x times x is x to the 3rd. And if you'll notice, there's nothing left over. So my answer here would be x to the 3rd. Okay, we're going to continue to extend this. You may not have noticed, but on the previous 2 examples, both of those exponents were even. What if I had an odd exponent? Again, process is going to be the same. I'm going to break this down into expanded form. So I know that the m to the 9th is really 9 m's. And sometimes it's tedious. We're going to find a shortcut here in a minute to write that down. And again, I'm going to circle pairs. So notice 1, 2, 3, 4 pairs. 4 pairs. But I also have an extra left over. So what I'll do is I'll take out all of those pairs. I have 1, 2, 3, 4. I have 1, 2, 3, 4 numbers that are perfect. However, I still have 1 that is not perfect. So I'm going to leave the 1 that's not perfect inside the square root sign. Simplifying that, m, of course 4 m's. M times itself 4 times is really m to the 4th with the square root of m left on the inside. Okay, and one final example. Let's look at the square. What if I have multiple variables here? Multiple variables. Just like all the previous examples, I'm going to write all these out in expanded form. This is our factoring method. So c to the third means I have c times c times c. D to the fifth means I have d, 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 d. That's 5 d's. And as before, I'm going to circle my pairs. I have one pair of c's, and I have two pair of d's. Notice I have leftovers of both of those. So I'll take out my one pair of c's, and I'll take out my 2 d's, and I will leave whatever is left over inside the radical sign. Simplifying that, I have c d squared, 2 d's, d squared, times the square root of c d.